Hello, and welcome to Luméa Wellness. As we journey through life, many of us notice changes in our physical strength and vitality. One of the most common is age-related muscle decline, often called sarcopenia, where our muscles gradually lose mass, strength, and their ability to repair themselves effectively. This can impact everything from our daily activities to our overall health span and quality of life. It's a natural process, but are there ways to support our bodies against it? What if a well-known peptide, one often associated with entirely different functions, holds a surprising key to helping our muscles stay healthier, longer? Today, we're exploring the fascinating potential of oxytocin in muscle enhancement and regeneration. You might know oxytocin as the love hormone, playing roles in social bonding and childbirth. But its influence, we're now discovering, is far more widespread. Exciting research reveals that oxytocin is a critical player in maintaining our muscle health throughout life. It's not just present, it's active in processes that keep our muscles robust. A key observation in the context of aging is that our natural oxytocin levels, and its receptors in tissues like muscle stem cells, tend to decrease as the years go by. And this isn't just a coincidence. Growing evidence suggests this decline in oxytocin might actively contribute to some of the muscle deterioration we see with aging, shifting our view of oxytocin to a potential active modulator of the aging process itself. So, how exactly does oxytocin exert these remarkable benefits on our muscles? One of its most vital roles is activating our muscles' own dedicated repair crew, the satellite cells. These are specialized adult stem cells residing in our muscles, always on standby, ready to spring into action to repair damage or build new muscle tissue. Think of them as the body's natural regeneration toolkit for muscle. Unfortunately, the aging process can impair both the number and the functional capacity of these crucial satellite cells, significantly slowing down muscle regeneration. This is where oxytocin steps in with striking effect. Studies have shown that when oxytocin levels are restored in aged animal models, muscle regeneration significantly improves. It's like a wake-up call for these cells. Oxytocin directly stimulates these aged satellite cells, enhancing their activation, their multiplication, and their ability to differentiate into new functional muscle fibers. It even boosts the expression of key muscle-building regulators like MyoD and Myogenin. The magic behind these muscle-boosting effects largely involves a critical cellular communication route, the MAPK ERK signaling pathway. When oxytocin binds to its receptor on muscle cells, it triggers a cascade of events, including an increase in intracellular calcium, which then activates this MAPK ERK pathway, essentially telling the satellite cells to get to work repairing and building. However, the age-related decline in both oxytocin and its receptors can lead to a state of oxytocin resistance in aging muscle. This is an important challenge to consider. But building new muscle isn't the only battle in maintaining muscle health as we age. We also need to combat another common issue: fibrosis. This is where excessive, stiff connective tissue accumulates within the muscle. This fibrosis makes muscles stiff, impairs their function, and actually hinders the repair process. Intriguingly, animals deficient in oxytocin show signs of premature muscle fibrosis. So, could oxytocin protect against this? One of the most exciting possibilities is that oxytocin may counteract the pro-fibrotic actions of a powerful molecule called TGF-beta. TGF-beta activity often ramps up in aging tissues, and it's a key driver of muscle fibrosis. By potentially dampening this TGF-beta signaling, oxytocin could offer a powerful dual benefit for our muscles. The fate of our muscle stem cells, whether they stay dormant, activate, multiply, or turn into new muscle fibers, is also governed by other complex systems, like the Notch signaling pathway. Oxytocin doesn't seem to act on Notch directly, but by activating the MAPK ERK pathway, it might indirectly help restore or appropriately modulate Notch activity, which is also often diminished in aging and is crucial for stem cell function and self-renewal. It's a delicate balance, and oxytocin appears to be a key conductor in this orchestra of regeneration. Now, oxytocin isn't the only peptide explored for muscle health. How does it stack up? GDF11, another member of the TGF-beta family, has had controversial findings. Some early reports suggested rejuvenation, but other studies indicated it might even inhibit muscle regeneration. If GDF11 does have profibrotic tendencies, oxytocin's potential to counteract such pathways makes it a more appealing candidate. IGF-1 is a well-known anabolic hormone that promotes muscle growth and repair, also using the MAPK ERK pathway like oxytocin. However, oxytocin may offer unique advantages for specifically activating aged satellite cells and its potential anti-fibrotic action we just discussed. GHK-Cu, or copper peptide, is famous for skin regeneration and wound healing. Its benefits in muscle seem more related to combating atrophy, improving mitochondrial health, and reducing oxidative stress, often via the SIRT1 pathway. This is a different, though complementary mechanism to oxytocin's direct action on muscle stem cells. Oxytocin's strength lies in its multifaceted approach, directly stimulating stem cells while also potentially improving the muscle environment by reducing fibrosis. So, the research paints a compelling picture. Oxytocin is a promising therapeutic candidate for tackling age-related muscle decline. Its ability to awaken dormant muscle stem cells and potentially fight fibrosis offers a unique dual action.